there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're solving harder problems involving ratios, our second video on this topic. Two things I need you really good at. The first is simplifying ratios. Pause the video and double check you can do that. So I would have expected you to be able to simplify both of these. The first one wasn't simple because the highest common factor of 9 and 6 was 3, and you could divide both sides by 3. The second one wasn't simple because they were fractions, and when a ratio is in simplest form, they must both be integers. So we've done questions like that before. Go back to your building blocks if you don't know how to do those. The next thing I need you super good at is writing ratios in the form 1 to n or n to 1. Pause the video, double check you can do that in these two cases. So all you had to do is decide which side you wanted to be 1. In the first case, the left side. In the second case, the right side, and do an appropriate division. And you would have got 1 to 9/5 or 5/9 to 1. And I need you really good at that for this particular skill. Right, let's get on and do a question. Here's a question. Pause the video, have a go, have a think. So it's telling us that we've got the ratio 4x to 9, and that's the same as 7 to 3. Now one thing we could do, and this is a foolproof method, if we always make one of the numbers 1, right, and these ratios are both the same, so if we made the second number in both cases 1 by dividing by 3 and dividing this side by 9, so that we got 1 here and we got 1 here, and obviously we'd have to do that to the other side as well, so we'd get 7/3 here and we'd get 4x over 9 here. Now we know those ratios are still the same, and we know that we've made this number 1 and this number 1, so the only logical conclusion then is the first numbers now must be equal to each other. So making both the second numbers 1 means the first numbers are the same, so we can say that 4x over 9 must be equal to 7 over 3. I could multiply both sides by 9 to undo that divide by 9. Think of it as multiplying by 9 over 1. And I would therefore get myself 4x is going to be equal to 7 multiplied by 9. Or actually we could cancel that first, divide that by 3, divide that by 3. You would therefore get yourself 4x is equal to 21. Divide both sides by 4 and I get that x is 21/4 or 21 over 4, and we're done. Now there is another way of doing it. It's worth pointing out to you. The other way of doing it is say you've got 4x to 9 is equal to 7 to 3. You could say all you've got to do is make one of those numbers the same, and then the other number will automatically be the same. And I'm looking at that and I'm thinking, well, if I multiplied that by 3, that would be 9. If I'd have to multiply that by 3, that would therefore be 21. Therefore, because these numbers are both 9, right, then these numbers here, 4x, must be equal to 21. And 4x is equal to 21. Dividing both sides by 4, I get x is 21 over 4. It worked out the same. So both options work. I'm going to stick with this making one of the sides 1 because it's foolproof for me, and I want to practice my algebra, but there are other ways of doing these problems. Let's do another one. Pause the video, have a go. Okay, same old stuff here. We've got 3x to 9 is equal to 7 to 5. I'm going to make the second number be 1. So I'm going to divide this side by 9. And I have to divide both sides by 9, so that would be 1. And remember, 3x divided by 9, that simplifies to x over 3. So I'm going to actually simplify it to x over 3 to 1. Now, if I make the second number 1 here, I'm going to divide both sides by 5. That's going to be 1, and that's going to be 7 over 5. Because this number and this number are 1, and these two ratios are the same, so we can state that x divided by 3 must be equal to 7 divided by 5. Let's multiply both sides by 3 to undo that divide by 3, and I get myself the answer. X is therefore 21 over 5, and I'm done. Next one, pause the video, have a go. Right, same old stuff here really. We've got ourselves that x to 9 is equal to 4 to x, right? So I've got to make one of the sides 1. It doesn't matter which one, but why don't I just continually make the second number 1? So I'm going to divide by 9. So that will be 1, and I have to do that to this side, so it'll be x over 9. And this side here, I'm going to divide by x. Now, we're asked to calculate the positive value of x. That tells us x isn't 0, so we're happy to divide by x. So it's not dividing by 0. So x divided by x gives me the one I'm looking for, and 4 divided by x is 4 over x. These ratios are equal to each other. This number is 1 and this number is 1, so the only logical conclusion is x over 9 must equal 4 over x. So x divided by 9 must be equal to 4 divided by x. So let's multiply both sides by 9, right, to undo that divide by 9. And what will I get? Well, I'll get myself x is therefore equal to 36 over x. Now I want to find x, and there's an x on the denominator here, so let me multiply both sides by x. And what will I get? I will get myself that x squared is therefore equal to 36. Taking square roots, I get myself x is positive 6 or x is negative 6. I obviously ignore negative 6 because the question told me to take the positive value, and my answer is therefore 6, and I'm done. Next question, pause the video, have a go. Okay, it tells us that we've got the numbers 3 and 8. What number needs to be added to 3 and 8 so that the ratio becomes 2 to 3? So before we do anything, so in the before scenario, we've got the numbers 3 to 8, right? And I add some number to them. Now I don't know what number I add, but I'm going to call it x. Why not? So I do 3, I add x to this to 3, and I add another number x to 8 there. So that's what the numbers are now, and that's their ratio. And it tells us that when I've added those numbers, the ratio becomes 2 to 3, right? So I can state that this here must be equal to 2 to 3. Now I can do the same old trick I've been doing so far. I can make one of the numbers be 1. This one's easy. I divide both sides by 3. That will therefore be 1. That will therefore be 2/3. This one here, I divide by 8 at x, right? I divide both sides by 8 at x. That would therefore be 1. This here would be 3 at x divided by 8 at x. Now because these ratios are equal to each other, and this one's 1 and this one's 1, the only logical conclusion is that 3 add x over 8 add x must be equal to 2/3, right? So I could say that 3 add x divided by 8 add x must be equal to 2/3. Now that's something we're going to have to be able to solve. Let's do it in stages. The first thing I'm going to do is multiply both sides by 8 add x. Okay, to undo the divide by 8 add x here. And I'm going to get myself therefore that 3 add x, I'm going to put a bracket around it, is going to equal 2/3 8 add x. Now I have to admit I don't like that dividing by 3 here, so I'm going to multiply both sides by 3 like that, and that would therefore give me that 3 brackets 3 add x must be equal to, that cancels that 3, 2 brackets 8 add x. Now I can expand. I get 9 add 3x is equal to 16 add 2x. Now I've got x on both sides. I'm going to jump steps a bit. I'm going to subtract 2x off both sides, right? And at the same time I'm going to subtract this 9 off both sides to try and solve for x, and I'm going to get myself x is therefore equal to 7. And does that work? If I had 3 and 8 and I added 7 to 3 and 8, I'd get 10 to 15, and 10 to 15 does simplify to the ratio 2 to 3. I got the right answer. Okay, last question. Pause the video, have a go. So we've got p to q is 3/4 to 2. We've got p to r is 1/3 to 1/2. Calculate p to q to r. Leave your answer in simplest form. So that's what we've got here. The key fact here is we've got ratios and both of them involve p. So p is the thing that's in both ratios. If we could, in this ratio, make p the same as what p is in this ratio, then we could use that fact to combine the ratios. Now what could you make p? Well, you could make p any number that's the same in both cases. Why don't we just choose 1? Let's just choose 1. Why not? It could be anything, but let's choose 1. So let's think to ourselves, what do I have to do to 3/4 to make it 1? I multiply it by its reciprocal, which is 4/3. So that would be 1. And if I did 2 multiplied by 4/3, 2 multiplied by 4/3 is going to be 8/3, right? So this ratio is 1 to 8/3, right? Now, what do I have to do to a third to make it 1? I could multiply it by 3, right? And that would make it 1. And 3 multiplied by 1/2 is 3/2, like that. Now there's some great news here. P is 1 in this ratio, P is 1 in that ratio. Now we can start combining them. We are trying to find the following. We are trying to get the ratio P to Q to R, right? Now what I've got is I've got that P in both cases is 1, so I'm going to write 1 there. Now when P is 1, I found from the first ratio that Q is 8/3, so I can write 8/3 there. And I've also found from the second ratio when P is 1 that R is 3/2, and that's our ratio of P to Q to R. The only thing is, it's not in its simplest form, is it? So to get it in its simplest form, let's undo that divide by 3, right? Because it's not in simplest form because it's a fraction. Let's multiply everything by 3, and I'd get myself the following. I'd get myself 3 to 8, and 3/2 times 3 is going to be 9/2, right? Now that's still not in simplest form because of the divide by 2, so let's double everything, and our answer now becomes 6 to 16 to 9, and we're done. And that is our ratio P to Q to R in simplest form. That's it for this video. Thanks for watching.